by now you're able to write your own SPSS files. You're able to write your own Excel files. You can also read in data. So in your own folder, you might have to reload the thing. So the thing which I've just written, like this coffee data, I could load it again by read_saf and then coffee data, the return. That will read it back into R. Yeah. So you could try to do the same thing for your team data. So this reading in data also works even from hyperlinks. So in this case, it's a .dat format, and so we can use a package called data.table, and this will read in by the fread function directly from a web link online. It will read in the data. So that's something which would be very difficult to do directly in SPSS, for example, also. And if we use head, we can see the first lines of the data that we imported. Yeah. So now I'm going to show you some basic data analysis and manipulations, and this largely follows Wickham and Grolemund. And so I'll told you about require as well. You can also have library, so I'll switch because they tend to use that. So this loads a database which is NYC flights. So you first have to install the NYC flights, and then you'll have a database. I install the tidyverse, and I use library to load it. It will give you some output with all these other things. What you'll see is that sometimes it will say it will give you some warning messages. It will say there's conflicts. What is happening there is that there's two packages using the same naming structure. Yeah. So there will be conflicts with some function because, for example, some of base R will also use the word select or divide or something like that, and the package is using the same wording, and that's creating conflicts for the computer. So if you want to use the base R version, our functions after these, you'll need to use the full name. So the base R package will be stats. So suppose you have filter both in a package called dplyr and in base R. R doesn't know which one to use. So you have to tell it, this is what I'm using, this is what I'm using. So again, many of the errors you'll get is that there's two packages using the same type of thing, and you haven't really told R which one it should be using. And then it will crash. And so this will use stats filter rather than the filter from dplyr, and this will use stats lag rather than the lag from dplyr. Yeah. So these are conflicts that exist, and it's not possible because there's only X amount of words in which we can say the same thing. So fix your conflicts. Okay, what's the NYC flights? It's a really massive data frame, so we're working with big data now. The biggest data set you've probably ever opened. It has 336,000 flights that departed from New York City in 2013. So congratulations, you're a data scientist after today because you loaded a really big data set. It's from the US Bureau of Transportation Statistics, and you can find out more information by using a single thing and flights. So we can call it directly. If we wanted to have our own object, you would again use this assignment operator to say, call it flights Thomas or flights Debbie or whatever. Otherwise, it will just be called flights because that's where it's living. You could see that then once we do it, it's going to try and print all those things, but it will stop after a certain rows, and that's because it's a tibble. And a tibble is basically a data frame, but with some additional bits and bobs to it. So you'll see that it will, for example, will print that this is an integer. It will print that this is a double, and it will print some additional information on each variable, which data frames don't have. So that's a tibble. So tibbles are like data frames, but with some additional tweaks to make data handling slightly easier. And you can turn a data frame into a tibble with as_tibble. So if you needed to do that, you can turn one into the other. What you should have noticed, which is what I just told you, is that it labels all these things like integers, doubles. It will tell you which type of variables are living in your data set. So character for vectors or strings, and you will also have things which are dates and times combined, and they will be dt, tm. Yeah. So if you wanted to see all 337,000 flights, I don't recommend you do that. You can use view, and then you'll see every single element in that database. Yeah, will then be printed to your screen. I'm going to teach you a little bit of basics in terms of manipulating data, which you will also have to do. And you can pick observations by using filter. You can reorder rows via arrange. We can pick variables with select. We can create new variables with functions using mutate. And we can use summarize to summarize variables. So let's do a little bit of data cleaning, so we can filter out all the things which have some missings in the departure delay. So here I make a new data set, and I recommend you do the same, so you don't override your own thing, so you make a new data set. So I use the filter thing. So here I make something which is called flights no miss. Yeah. So it's a new object, a new data set, which is going to have all these 336,000 flights in it. So I don't override things. I'm using the filter command. So this is after I've wrote this tidyverse package and dplyr so that the R has access to this. Otherwise it will say, I don't know what filter is. How do I filter? This is the object which it has to do things to, which is the flights database. And this is saying, remove anything which is not missing. Yeah. So that's filtering. You could see this type of things for commands, like you have and, is, or not for logical operations. And so this exclamation mark and is means is not. Yeah. So when filtering, you usually need this, like larger than, smaller than, equal to. Yeah. And so this is not equal, and this means is equal. Notice that it has two is's, and that's because a single is a mathematical operation, and this is a logical query. This is asking the computer, is something identical to this? So you could use is with numbers, but you need the double is, for example, for saying, is it from JFK airport or something else? So you need these double quotations. So these are logical operators which you'll use to filter things away, and so we could use the same thing to filter other things away. Another important point is floating point numbers. So they're a problem. So computers cannot store an infinite number of digits. And so when you use these things to say this is not 2, for example, you have to bear in mind that the computer cannot store 111.999999 as 2. So that's the issue. So if we take the square root of 3 and square it back, it should be 3. But it's not. That's weird, because it should be the same thing. If we understand basic maths, it should be the same thing. The issue here is rounding. So, the same if we divide 1 by 98 and times it 98, basic maths should say it's the same thing, but it's not. That's because the computer cannot start all the decimals behind it. There's a limit to it. Yeah. So that's a floating point number. So the solution to that is using near. So for example, if in your logical operations you have something which has very large number of digits, you're going to have to use near to say it's close to that. Yeah. So this applies to when you take square roots or when you take divisions over over some numbers where you have lots and lots of decimals. At some point, the computer is going to say, I can no longer store this. Yeah. Okay, so now we can do some basic statistics. We can look at the delays with departure. That's a departure delay. And so remember, I have flights no miss. And this is how I calculate the mean. So this is the dollar sign. Is there a class going on here? I'll check. Is there a class going on here? Okay. I don't think there is. But I could be wrong. Okay. We'll see. If more people barge in, then I'll terminate. So you can see that this basically, so far for the inner piece, this is our database, and we use the dollar sign to call the variable in that database. So this will call departure delay, yeah? So this will call that variable. And so this will calculate the mean. And so this is 12 minutes, because everything is expressed in minutes. So on average, of those 300,000 flights or something, on average, they depart 12 minutes late. Yeah? We can also get the median. You remember that the median is not the same as the mean. Yeah? The median is -2. So if we take the 50th percentile of that distribution, on average, the median is 2 minutes early. So if we take the 50th percentile of that distribution of all the flights leave 2 minutes early. You remember measures of variation, so you have means and standard deviations. We can get the standard deviation via SD. Yeah, so how much variability is there around this mean? And that's 40, so that tells you there's quite a lot of variation around this mean of 12 minutes, so quite a lot of variation. Probably some flights which leave really early and some flights which have really horrendous delays. We can also get the variance. You remember that is nothing more than taking the square of the standard deviation. If you go back to your undergraduate statistics, and we can, based on that, we can calculate the standard error. So there is no standard error function, but if you go back to your undergraduate statistics, it's the standard deviation divided by the square root of n, and n is how many cases we have in our database. So we use length to say how many cases do we have. Yeah? So this will calculate for us the standard error of the mean. And the standard error of the mean we expect to be a lot smaller. So you can see it's actually quite small, right? Because we have lots and lots of flights, so we're going to be dividing by a very large number. Yeah? As you remember from your undergraduate statistics, we can calculate the 95% confidence interval around the mean by taking plus or minus 1.96, the standard error. Again, it should be nothing new. These are all basic statistical things which you did in your first year. We're just using R for it. So this is the 95% confidence interval. So it's quite a narrow confidence interval. So it's just around 12 minutes. Yeah. So between 13 and 12.5 or something around. Okay. But we can also ask a 5-number summary, and that's the minimum, the first quartile, the median, the third quartile, and the maximum. So the first quartile is the 25th percentile and the 75th percentile. Yeah. So minus 43, so 43 minutes early, and I don't want to be on that flight which leaves 1,300 minutes late. So quite a big delay. And we can also do it in a different way. We can ask summary, and then it will print it and say this is the minimum, this is the first quartile, this is the median, this is the mean, this is the third quartile, and this is the maximum. Okay, everybody still with me? So basic statistical operations on a variable. You remember that we can have as a measure for variation also the interquartile range. So we can take the third quartile and the first quartile. I remember from box plots we use 1.5 times the interquartile range to plot a measure of variation. So we can do that, and it's, if you go back, it's nothing more or nothing less than subtracting or taking those two numbers that we had here, like minus 5 and 11. Yeah, so that's the range between those. It's 16. We can make a very basic box plot by just saying box plot. You can immediately see it's hugely skewed. This is this unlucky flight with 1,300 minutes delay. Lots of flights which are sort of have extremely large delays, so you can see that there's some issues there. We can also ask from our data what is the mode, and the mode is the most common value, so which is the most frequently appearing value in our data set. We can use a package to do that, and we can use modest, which is mode estimator, yeah. And then we can say, we'll print some things like, some things are overwritten. Then we can say, give me this, and this is a method in which to estimate it. You're just going to have to copy the you're just going to have to copy that code, because you could have the case that you have similar type of numbers which are the mode. So if 5 and 3 are the most common numbers, then the computer doesn't know where it's 5 or 3. And this MFV is a method of estimating the modes if you have cases with ties, for example. And the most common value is minus 5. So the most common value in that database is 5 minutes early. Okay, we'll go a little bit. No, we should stop. So I think I've gone 10 minutes over. I can see your. So I didn't reach all the way to the end, but you can. I expect you to look a little bit further towards the end of the slides. If you feel really confident, you can start doing the exercise because that's already available to you. If you don't feel confident, I'll pick it up from there, and then you can submit the exercise next week. I'm not hugely behind, but occasionally it will happen because I think it's important that you also practice a little bit on your own. So for next week, try to look at the slides again. Try to do the in-class exercise if you didn't finish them. If you feel very confident, try having a go at the exercise at the end of these slides, which is nothing more, nothing less than the things which I've done, but with a different variable in the flights data set, and that's it. Okay, so next week we'll pick it up where we left, and then we're going to talk a little bit more about some basic statistics. Any burning questions so far? No? Everybody's on Blackboard? If you're not on Blackboard, try to get on Blackboard really fast. And occasionally I might go slightly over time just to catch up, and you still have a long lunch break, so. Any burning questions? come and chat to me now or post them on the Blackboard. And make sure that you sign into the register if you haven't done so already.